Well, it's quite unfortunate. What can I really say? Hello, everyone. This is your nerdy Kostya. Today we're going to be testing GPT 5.5, yes, within Codex. I'll be using the Codex CLI. A brand new model has just been released. The most important thing to mention, yes, is that it has gained agency. So this means you don't have to write step-by-step instructions. The model itself decides how to carry it out, yes, even if we give it some simple instructions. Additionally, it's capable of working with the entire project without losing context and so on and so forth. Therefore, in an ideal scenario, we should be getting a direct, concrete result. Furthermore, it's proficient in working with visuals, user interfaces, and underlying logic, and essentially acting as a full-fledged developer. It can directly construct an entire project. When you look at the cost, it's actually quite an expensive model. From what I understand, it's actually the most expensive model available right now, even surpassing Opus in price. But as they claim, it actually uses significantly fewer tokens, right? This means it doesn't squander or waste tokens like the previous models did. That's exactly what we're going to find out today. Today I'm going to conduct 4 different tests for you, and we'll see just how real all these parameters actually are. I have a good friend also named Konstantin, and he's actually the one who shoots videos exactly like this, you know? And he conducts some really cool tests there for neural networks in order to showcase their full functionality. For today, I've prepared 4 different tests. Yes, you'll need to create a rabbit cat, basically some 3D hamsters, a Tamagotchi with a developer, and well, to come up with, or rather to build a website. I'll be using Codex 5.5 via API today. Right now, I'm testing the platform. So for 250 rubles, I bought a $100 key. Yes, I only spent 350 today on all the tests. So, and the only thing from Claude that I have to compare it with is 4 and 6. In some moments, I might compare it to that. It's understandable, of course, that it's not 4 and 7, but at the moment, we don't have the opportunity to test exactly 4 and 7. Let's proceed to the first test. To do this, we simply drag and drop the instructions, and then we type in create a project based on the specific instructions. That's it. We just hit enter. It then begins its work, and our only task from that point on is simply to wait. All right, then, he has successfully completed the task for us. He managed to complete the entire task for us in literally just 2 or 3 minutes. Let's take a look now at what we've actually ended up with. To do this, we simply need to open up this particular file. It's just the index.html file. This is how it looks, some kind of rough code. He's going towards the glass of water. Let's see when he's about to drop it. See that? Let me explain what this test is about. First, the cat is drawn entirely using CSS, right? Second, our task, yes, is to observe the coordinate system's operation. Yes, does the AI truly understand the physics of elements? Our goal is for everything to move smoothly. Yes, for the glass to actually fall and for the glass to genuinely react when the cat approaches. In our case, it really works, but the glass falls a bit too late. So, as you can see for yourselves, everything isn't entirely perfect, but it does work in principle. And all of this remarkably was generated from just one single prompt. So now let's take a closer look at how this whole thing actually operates, and then we'll play this game. So what we need to do is click on the cat, which means we have to scare it when it's about to approach the glass. Yes, that means we absolutely must not. We cannot allow the cat to get close to the glass, and with every single press, the cat just keeps getting faster. So you see, this particular task is actually being completed.
Awesome.
It's over, the cat won. What can I say? I really like it. We can compare and then see how Claude 4.6 manages this task. The prompt we're using is exactly the same. We're going to feed it to him, yes. Using this specific instruction, create a project for us, and then we launch it. And we're waiting to see how long it will take and how quickly our Claude will manage this. All right, Claude also managed to finish in about 2.5 minutes, right? He wrote this kind of report. Let's take a look at what he came up with. Okay, so first off, we have the title screen. That's one point. Now look, the cat is drawn much better here, but his actual movement, his walk, is worse than it was before. And the physics is done incredibly well. Yeah, I mean, he hit the cat, oh, the glass, exactly where it was. So let's see now what's going to happen next. We're about to press it now. Oh, that's really great. You see, the sounds have been implemented. I mean, when we interact with them, for now, I definitely prefer Claude much more. Let's take a look. Everything is speeding up, everything. It's harder to play, but the game looks more polished, though here the cat moves more logically. But even graphically, for me, the winner here is definitely Claude 4 and 6. Note, this is the previous model. Alright, so now we're moving on to our next test. And the next project we're presenting is what we call the Tamagotchi. Yes, we've actually created a junior Tamagotchi. It's an interactive dashboard designed specifically for developer survival. In the center, we have a large icon for June, and beneath it, 3 dynamic scales: stress, caffeine, code quality, and the current deadline. Why are we doing this? We're simply transitioning from basic movement to complex mathematics, aren't we? In real-world web applications, data is constantly being updated. And this is exactly the kind of test where we have quite a lot, well, not really that many. We have certain variables. They are dependent on each other. Yes, we want to see how artificial intelligence balances when there are multiple dependent variables, how they function. We need to check if our scales go into minus 100% or beyond 100%, and if they process visual triggers, meaning our interface starts to break and spin. When the code crashes, the quality of the user interface must inevitably decline. In precisely the same manner, if there is an excessive amount of caffeine, the screen begins to pulsate. Let's pause, proceed to launch this task, and observe how our neural network will manage it. It took him approximately 3 minutes to complete this. Let's take a look now at what he has managed to achieve. So what we're seeing here are the stress level, the caffeine level, and we also have the code level. In general, if we consume coffee, our stress level decreases, but the caffeine level then increases. If your caffeine level starts to approach 90, you see the screen begins to flicker. Yes, it's the same thing. To relieve stress, we can simply copy code from Stack Overflow. Our code quality drops, but our stress levels also decrease, or we can increase the code quality, but then we have to write it ourselves. Then our stress levels increase and it starts to go completely mad. So we quickly drink our coffee and then copy the code, but if the code is faulty, then you see everything just crashes down. To put it simply, he gave it his absolute best effort. I was truly impressed by the way he managed to get everything done. So, what are our options then if we consider it? We could completely break the code and everything would turn out perfectly fine for us. We can drink too much coffee, everything starts to blur, and we can write code. But if our stress level goes above 100, then we're burned out. I won't even compare it with Opus. I liked how they did it here. I just didn't like it there, and I was curious what Opus would do. But here, I absolutely loved everything. Everything is done really well. Let's move on to the third test. Well, and for me, the most highly anticipated test, I'd say, is 3D programming. Wouldn't you agree? We are going to be building a 3-dimensional hamster cage. This means it's a truly full-fledged 3D scene right within your web browser. Yes, we're utilizing a JavaScript library for this, and we can clearly see a cage with hamsters crawling chaotically inside and a running wheel in the corner, so the scene can be rotated and zoomed with the mouse. What are we doing then? We're stress testing heavy libraries, right? And furthermore, we are examining our model's capability to think abstractly, right? So let's go ahead and run our prompt now, and we'll see what our codex is going to do for us. Here, by the way, I also want to immediately try to involve Claude and see what Claude does for us. Then we'll compare who does it better. Let's launch it here too. All right, well, both of our neural networks have successfully completed the task. One of them, Codex, managed to do it in 3 minutes, right? And then Claude, on the other hand, finished it in approximately 1 minute 40 seconds. So let's now proceed to take a look at the actual results. To start things off, naturally, we'll examine Codex's output and see exactly what it has generated for us.
He did it for us.
Nothing. It's not working for us. Let's take a screenshot of it and save it as an error. Okay, and let's immediately see what Opus also did for us. All right, Opus actually performed significantly better. Here we have these hamsters and their cage. That is to say, it worked perfectly right from the very first attempt. By the way, I had already done a preliminary check before this, and Codex actually performed better last time. Honestly, the cage itself is quite something, and the wheel is really quite peculiar, to put it mildly, isn't it? I mean, they come up. Well, something is appearing over there, but it doesn't quite look like it's meant for the wheel. But despite that, he managed to get it done straight away. Now let's attempt to write it down to properly refine it so that our codex, yes, we can tell it. Take a look. Look, there is absolutely nothing at all being displayed. Correct it. It's not working, and that's it, and we'll just wait for him to fix it. Well, he took quite a long time to send it. Let's see what he's done for us this time. I understand what you mean. Well, to be honest, it's quite a sad situation. What more can I possibly say? So this is the kind of mistake that we've ended up with, isn't it? So generally speaking, what else can I really say about it? In that initial test, he actually performed significantly, much better. I'll even go and locate the specific file right now, and then I'll show it to you. This, by the way, goes to show that neural networks are unstable, right? For example, last time Claude performed terribly, and this time Codex is still struggling with something. I'll certainly give it one more try, one more chance now, but I'm not happy with it. But for now, let me just quickly locate the specific file that it generated for me during my previous attempt, back when I was doing this without actually recording the video. The prompt, in case you're wondering, was exactly identical, and this particular cell here was also created by ChatGPT, yes, by Codex. And here, take a look. Unlike Opus 4 and 6, it's actually right there in the wheel. It shows the wheel in full 3D, you know, whether it's free or occupied and so forth. I mean, this I definitely like a lot more than what Opus managed to do. But now, let's see, what exactly do we have here? Neural networks are inconsistent. What I mean is, sometimes it makes sense to simply create a new dialogue and try again, because the prompt was just one. And this is what Codex did. It was generated from exactly one prompt last time, right? And now what do we see? We are seeing an error now. I gave him one last chance to fix it. Let's see what he does. If he doesn't, we'll skip this, and then it's a clear win for Opus in this specific race, in this specific query. This is really quite interesting for this very reason. I think it's worth doing these tests to demonstrate the instability of neural networks even now. And look, he just corrected it. So what is it that we have? Our hamsters are better. They're actually way, way better. Even more so than the previous version. They have proper little legs, all the works. What I like is that they even included glass in the cage. This is quite interesting, even though I didn't actually ask for it, but the cage is right here. Have a look. The hamster runs on its wheel, and now it runs even better than in the previous version, but the wheel, you see, has physics. So when it stops running, the wheel continues to spin. Anyway, it's really, really well done. But remember this, you see, we actually managed to do it on the third attempt. And Opus, on the other hand, completed it on the very first try. But nevertheless, I still believe the final result is excellent for both Opus and Codex. But unfortunately, in this test, for some reason, Codex didn't get it right the first time, unlike last time when I did it without recording. Alright, let's move on to the fourth test. And for our final test today, we need to create a website. We'll get a ready-made, stylish and expensive dark-themed landing page for a fictional corporation. Yes, we're putting aside all these games and playful modes. We're truly just interested in getting a really good, solid, well-built website, you know, one that has various UI elements, and we need to observe how it all operates. So I won't ramble on. I won't use Opus here, we'll just stick to Codex. So we'll launch it and wait for it to finish. Well, dear friends, we've waited. Let's open it and see. Here's what we have. There's a dark and a light theme available. Yes, let's first take a look at everything in dark mode. Okay, everything seems to be perfectly fine. And yes, the animation is definitely present here. However, I'm really not quite sure what the specific element is. And regarding the fonts, it appears that nothing is being cut off at any point. It appears that all the buttons are functioning correctly. Yes, so far everything is looking pretty good. Do we have any interactive elements that we can use? Yes, a slider. The slider is functioning perfectly. Reviews.
Something here has gone a little bit wrong.
Lists which are able to be expanded.
Well, it's just mediocre, and he really made it worse. Damn. Let's try looking at it again, using the light theme. Do we have anything that floats? Oh, damn, that's cool, by the way. He also made the light theme. It's interesting, though, when I recorded without this, he made it more interesting. Let's check its responsiveness. Let's switch to dark. Let's choose iPhone 14.
Oh, that's totally awesome.
On the mobile version, it actually looks even better. The images, of course, are a bit narrowed. It would have been better naturally if he had kept them at their full resolution, right? They are supposed to be widescreen, but nothing seems to break. Yes, everything in the mobile layout, by the way, actually looks even better. So, well, I believe he handled the test beautifully and quite originally.
I really like it. Yes, of course.
Look, some animation over there.
What's that thing lighting up over there? What is it?
Oh, this is the one that came from Yandex. So everything is working perfectly. Reverse it.
So these are the tests. As for my personal opinion, yes, this is my very first video and I don't really have much to compare it with just yet. I will definitely continue comparing new models as they are released, okay? I'd like to film a video about DeepSeek V4. Please write in the comments if you find this interesting. To me, the AI handled all the tasks perfectly, didn't it?
With the hamster, of course, we had to fuss around. Let's quickly take another look at what it has done.
She made us a game, you see, where I have to stop the cat from getting to the glass. The more often we press the button, the faster he starts to speed up. It's done quite well. There are some flaws, but this is from a single prompt, I should point out, right? Then we made a junior simulator, right? When he's under stress, he just loses his mind. We need to quickly copy it. If the code quality drops, then everything just falls apart. Though perhaps we should have also made it so that it's scored 0 for code quality, right? If we write the code ourselves, our stress increases. So essentially, we've established a rather complex dependency of variables right here. You see, if we happen to drink too much coffee, then everything starts to flicker. Following that, we constructed a particular cage, complete with hamsters inside. It certainly took a considerable amount of time, but it performed better than Opus 4.6 in certain aspects and not as well in others. But the fact is, it was on the third request, though. I must reiterate, last time I did it on the very first attempt. And finally, they put together this small landing page. There are some flaws as well, but overall, for a simple request, and my prompt wasn't even super amazing, it still looks quite excellent. That's all for this one. We'll catch you in the very next video. This has been your drowned Kostya. Bye everyone.